Welcome to part 2 of my series on surds. This video we'll be looking at algebra with surds, where we're going to be adding surds together and subtracting them and multiplying them and dividing them, that kind of thing. Alright, so we can manipulate surds in the same way that we can manipulate letters. If you imagine something like this, where we have x plus x plus x. It's pretty straightforward to come to the conclusion that it equals 3x. No problem. Surds behave in a similar way. If we have root 2 plus root 2 plus root 2, you can just think of it as if it were an x, because it simplifies to 3 root 2. There are 3 of them, 3 root 2. Okay, so just like we can't add different letters, we can't add different surds. Different surds act as like terms, just like different letters do. Okay, so let me show you how that looks. Suppose we have something like 2 plus 3 plus x plus x plus y plus y. And most of us would be pretty confident to say that this is 5 plus 2x plus 2y. The surd equivalent would be maybe something like this. Suppose we had 1 plus 4 plus root 3 plus root 3 plus root 5 plus root 5. That would become 5. Which is those guys, plus 2 root 3, which is those guys, plus 2 root 5, which is those guys. Cool. Sometimes we have to simplify the surds before we can add them. Imagine this scenario where we're asked to simplify root 25 plus root 20 plus root 50 plus root 72. Remembering back to our previous video, we can simplify all these. Root 25 is 5. Root 20 will go like this, 4 times 5. Root 50, we can go 25 times 2. And 72, what are we going to say? 9 times 8? Maybe. But I have in my notes in front of me 36 times 2, which will get it a bit quicker. So this is 5. This is 2 root 5. This is 5 root 2. And this is 6 root 2. I skipped a step there, and you can refer back to the previous video if you need help with how we got from line 2 to line 3 there. You can see now that this one and this one are like terms. So our final answer is 5 plus 2 root 5 plus 11 root 2. Some calculators might have it as the root 2 coming before the root 5 because it's a lower one. It's a personal preference, in my opinion. Alright, that's adding and subtracting taken care of course, because subtracting works in much the same way. Let's talk about multiplying surds. Do a little heading. Sorry for the messy writing. Multiplying surds. Okay, here we are making use of the following rules. Root A times root A equals A. This is kind of like an index law. If you remember back to fractional indices, where we had root A is A to the power of a half. A to the half times A to the half What do we do when we're multiplying together things and they have the same base? What do we do to the indices? You add them. So this is a to the 1, which is a. Long story short, if you've got two things and you multiply them together, they're the square root of each other, then you get rid of the square root sign. The other sort of rule that we're using is if you've got root a, actually I'll do that in blue just for keep it all neat and tidy. If we've got root a times root b, it equals root AB, like this. Okay? This is kind of like the reverse of the splitting rule that I kind of introduced when we were doing simplifying surds. Okay, let's do some examples. Simplify root 5 times root 5. You can probably already guess what this is. It's going to be 5. But you can just look at the other rule as well. It's allowed to combine like that, and root 25 equals 5. Easy peasy. Alright, let's do another example. Root 5 times root 3. This equals root 15.
Hello.
Hello, Leon. We'll do one final example. I'll do it in red. We'll go 2 times root 5 times root 5 times 3. We can multiply the number bits together, 2 times 3, that's 6, and root 5 times root 5 is root 25. You can simplify root 25 to 5, and then 6 times 5 is 30. Done deal. Alright, let's talk now about dividing surds. Dividing surds. Okay, here we're following the rule that says root a on root b equals root a on b, like this. We can use this to simplify surds which are fractions. So let me show you some examples. We can have root 55 on root 5. You can combine root 55 on 5 and then simplify the fraction underneath the radical sign. Root 11. Finished. Second example, 9 root 88 on 6 root 99. We're going to start by splitting this up. Just so we can work on the number bit and the surd bit separately. 9/6 is going to simplify to 3/2 if we divide top and bottom by 3. And root 88 on root 99, well, we can combine the surd like this. We can simplify on the inside. They're both in the 11 times tables, so I can divide through by 11. we can split the surd back up like this. Root 8 is going to become 2 root 2 using our simplification method from last time. Root 9 is going to become 3. Now to multiply fractions together. Multiply top by top. 6 root 2. Bottom by bottom. 6. And cancel. It's a long question, but a good one. Thank you for watching and have a nice day.